All right, my name is Jesus Solis, and this is my presentation on DNA replication. So we have here our DNA going from 3 or 5 prime to 3 prime and 3 prime to 5 prime. That is a double helix, and right here, this part, if we actually blow it up and we make it bigger, this is how it would look. So first thing that needs to happen is the DNA helix, it has to unwind. For that, we have two different types of enzymes. The first one is helicase. Now, helicase is going to be these little triangles. They're like forks. They are actually going to start opening the helix in order to make a replication bubble. Now, the more they expand, the more that the helix would actually start twisting tighter and tighter because of all the pressure. For that not to happen, we have another enzyme. The name of the enzyme is topoisomerase, and this enzyme is right here, and it's actually in charge of maintaining the DNA helix from twisting too hard. So the first part is unwinding, the second part is replication. On the replication, we have right in the middle of our replication bubble the origin of replication, and it's on both sides. Okay, so from here we are going to need two different enzymes. The first enzyme is the one that is going to replicate everything. That one is a DNA polymerase 3. However, the DNA polymerase 3 can only add to the 3 prime and needs an existing 3 prime end in order to add or to start. All right, so the primase, which is the enzyme, will create the RNA primer, which is going to be here. This is going to have the 3 prime end, and the DNA polymerase 3 is going to use that to attach itself to it and start replicating the DNA. So it would go from the origin of replication. When you go on a straight line that is unbroken, that is going to be your lead strand. But behind the origin of replication, every time you have to put more RNA primer, and then the DNA polymerase 3 has to start adding, and then it's going to happen here again, and then later on it's going to happen here again. So this strand is the lagging strand. Same thing for the top. Since this is the point of origin, this is going to go one way, unbroken. And that's going to be the leading strand, versus on the other side that you're going to have the system, I guess, is going to have to put more RNA primer for the DNA polymerase 3 to start creating more replication. So again, lagging is going to be the one that has to be broken, and every time it's broken, it's going to be a Okazaki fragment. All right, so let's say that the whole replication has been done. We already unwinded the DNA. We were able to replicate it. Now it's time to go, and we have to, let it be like it was. So in order for that to happen, we have DNA polymerase 1, which will cut out the RNA primers, and is going to put, instead of here, is going to replace it with DNA. Once that happens, DNA polymerase 1 will create more like a a sequence of DNA that is going to still be broken with gaps. However, a second enzyme comes, and this one is ligase. I think that's how you say it. And this one is going to seal those little gaps to make it into one continuous line. And that is DNA replication.